Welcome back, Algebra 2. In this video, we'll be defining and practicing using complex and imaginary numbers. Before we do that, let's get some practice with solving. So let's go ahead and answer number 1, which says, how can we use square roots to solve each equation? Well, if we take a look at part A, which is x squared equals 16, if we're trying to solve, we want to undo the power of 2 that is acting on that x. So to undo a power of 2, we want to take the square root. Now, whatever I do to one side, I have to do to the other side. So I'm going to take the square root of both sides. Now, when I do that, I want to make sure that I also get both the positive and the negative component. So what that means is I know that I'm going to have two solutions here. So one of my solutions is going to be 4. The other solution is going to be negative 4. And we can refer back to video 1 here, and we see that this value here, this is positive. And so that means I'm going to have two solutions. So I can write that as x equals positive or negative 4. Okay, now let's take a look at part B. So part B, we're going to follow a similar process. We're going to start off by taking the square root of both sides. Oh, but when I do that, I am actually seeing that I'm taking the square root of a negative 9. So right here, we're going to go ahead and write no real solutions, because I don't have the tools right now to take the square root of a negative number. But that's where complex and imaginary numbers come in. They're a tool that help us, that were created to allow us to take the square root of a negative number. So let's go ahead and define that. So a complex number has the structure a plus bi. A is the real number. Those are the numbers that we're familiar with. That's the real component. And the bi, that's the imaginary component. Okay, so complex numbers have a real component and an imaginary part. The number, the square root of negative 1, is called the imaginary number. Because up until now, I didn't have the tools to help me take the square root of a negative number. They haven't been created yet. So when we need something, that's what mathematicians do. We create something that allow us to do the processes that we need to do. So what we're going to do is replace the square root of the negative 1. We're going to say that that stands for I. Those two things are equivalent. So now let's go ahead and take a look at part B again. So now I can take the square root of negative 9 and rewrite this as the square root of negative 1 times 9. Because that would mean that my first line and second line are equivalent. In my third line, I can go ahead and separate that square root and write it as two different ones. We can do that under the square root when I only have multiplication. So now I can replace this negative 1 here with I, because that's what we're saying is the imaginary part. So we're saying the square root of negative 1 is the same thing as I. So we're just going to replace that. Oh, whoops. So instead of writing the square root of negative 1, I am going to write I. And now the square root of 9 is something that we already know. Well, the square root of 9 is just 3. So I really have I times 3. And one thing that I forgot to say is that we want to make sure that we have the positive and the negative component. So our solution is x equals negative 3i and x equals 3i. So that is how we can write our two solutions, and we can write that in this line over here as well. Whoops. Okay, so once again, imaginary numbers were created to help us take the square root of negative numbers and find complex solutions to problems like in 1B. Let's do some practice together as a class. So on your own, give me the solutions to x squared equals negative 36. And then come back to class and we'll discuss the answer.